Just to show you how mad this conference is, we actually now have hard-working messieurs. Hard-working, very hard-working messieurs.
We're totally gorgeous.
For poor geese in San Francisco. I'm sure they're doing a fantastic job as well. Yeah, I'll put you. What's your URL?
Sorry,
what is your website?
Oh, I am a cancer.
Oh.
And a Chinese monkey.
Okay. Alright, good job. This is JavaFX.
It's an object-oriented language, and it has some unique features that I think allows us a more direct expression of these kinds of programs. One of those is declarative syntax. As I mentioned, it's a statically typed language, but it has some degree of type inference. So the number of type annotations that you have to put into your code are, a lot less than what you get in Java. It also has first-class functions, closures, and a number of other interesting features from the world of functional languages. It has an extensive library which encompasses both Swing and Java 2D, and we have some plugins for the NetBeans and Eclipse IDEs. So the next question is, well, exactly what problem are you trying to solve here? And to me, fundamentally, the problem is, how can we make GUI development more efficient? How can we build applications, the applications that we want, or the stakeholders in our project want, and deliver those applications and deploy those applications and have them be used in the real world as soon as possible? So, as we know, GUI development involves a number of participants, content designers, the people that determine what information has to be communicated through that GUI to the user, and what kind of interactions they would like to see the user having with your application. The graphic artists who create the artwork, who create the graphic elements, the visual elements and design the visual elements that appear in your user interface. And finally us, the programmers, who have to assemble this all together and give it the behavior that the content designer wants. From my observations working with the other participants, they get their part of the job done pretty fast. I've worked with UI designers, and in a couple of days they can create some screens and some icons and various pieces of artwork, and create a mock-up of a user interface that is quite compelling. In a couple of weeks they can create a mock-up of a very complex application. But from my observations of GUI programmers, on the other hand, we're talking more in terms of months and years for them to produce results. So my question was, what is it that's making us inefficient? Is it possible for us to be able to accomplish things in a much shorter amount of time? So we can get an iterative process going. But UI designers and content designers, provide some designs, and we can iteratively create a prototype, and experiment with it and explore it, and send it back to them to adjust the design and improve it, and repeat that process over that several month or many month period, rather than waiting for only one iteration at the end. Okay, let's take a look at the ugly Java GUI. I'm sure you've all heard this. The ugly Java GUI is some kind of gray box thing with some tables and buttons on it. So this is, in my opinion, from my observations, this is an artifact of taking advantage of the only compositional framework that we have right now, which is the AWT container component hierarchy. It's a useful tool because you can compose higher level widgets from lower level ones by putting them together into a panel or some other component using layout managers and so on. However, if that's all you do, you tend to end up with a certain stereotypical looking user interface, and rarely does it correspond to what the UI designers have in mind, or the content designers. The same kind of problem exists with other toolkits. And I think I mentioned GTK and VB. You see the same type of so-called ugly GUI. So the problem here is that the UI designers themselves are not building their designs that way. They're using tools like Photoshop or Illustrator or Inkscape. And they're creating those designs using 2D graphic elements, shapes, gradients, and so on. And they're actually direct analogs of all of these things in the Java platform. However, it's in Java 2D. And not just in AWT. So here's an example of the stereotype, I think. I showed this to Romain Guy. He said, ouch. That's where that title came from. So this is a PDF, a Java PDF renderer, and the actual PDF renderer looks very nice. They rendered that slide very well, I would say. But the rest of it looks pretty bad, okay? So we have a JTab pane on the left with some poorly rendered text, vertically rendered, and the thumbnail views are actually, believe it or not, J buttons with the icon and text implemented using a J button. It's inside a scroll pane with a kind of funny looking split pane splitter. The layout of the various controls is terrible. No UI designer would have ever designed it that way. And this is what happens when you just have a programmer assembling things just using, you know, swing components and your typical layout manager. So what we want to be able to do is let the Java GUI programmers give them the same building blocks that the UI designers are using, and you can assemble it so that you can assemble them in the design as specified in the way that they would like to have it. So here's the first demo, and actually you're already looking at it. I'm showing my slides in a PDF reader that was written using JavaFX, and this actually uses a renderer that was written by a guy who used to work in Sun Labs a few years ago, back in 2003. It's a pure Java PDF decoder and renderer, but the rest of it is written with JavaFX. And you can see we have and also the design of the graphical design was not done by me, the programmer, sorry about that, but by one of our UI designers that works at Sun. She came up with the icons and the design of the layout, and I just implemented her design. So we have some, you know, animated zooming and, whoop. Oh, this is tricky. Using the mouse on this setup is tricky. You can fit the slide to my size of my viewport, and we have sort of like a faux 3D thumbnail view. And this is what she came up with, and I just implemented it. So I think hopefully this shows you that our Java GUI programs don't have to look like that, and can look as good as GUI programs written in any other platform, including Flash, and so on. Okay, so as I mentioned, to match the designs of the UI designers, you have to use Java 2D. But Java 2D does not have the compositional behavior like AWT does. And as a result, from my observations, the barrier to entry for many people to try to use it, I mean, of course you can override paint component on your swing component and use Java 2D to paint whatever you like. But then when you want to try to hook that together with other such custom swing components, there's no functionality to do that. So what JavaFX does is it provides a compositional framework for combining 2D graphics. So in JavaFX, not only are swing components, a rectangle is a component, a line is a component, a circle, an ellipse, any shape. And you can put mouse handlers on those components, you can group them together, and you can move them around as a group, and so on, and compose them together into higher level components. And finally, the JavaFX language allows a declarative expression of this composition. Okay. So this is a little tutorial that's actually written using JavaFX. It's available on the public website, which I'll give you the URL later if you're not already aware of it. And it consists of a canvas, which is this part right here, and a code editor. So whatever you type in, it's kind of like a glorified read eval print loop that some of you might be familiar with some programming languages. So whatever I type in down here, whatever visual element I create down here will be displayed up here. So these are the basic building blocks for creating graphical user interfaces. So we have a bunch of built-in shapes. We have a rectangle. And the JavaFX language provides a declarative interface to creating these things. So here I have a rect object. It has the origin at x equals 20, y equals 20. So its origin is at 20, 20. It has a height of 80 pixels, a width of 300. And it also has rounded corners. It's a round rectangle. So the arc height and arc width attributes determine the roundness, how rounded the corners are. It's filled with a cyan color. The stroke, which is the border color of the shape, is purple, and the width of the stroke is 2 pixels. So I could change these attributes and immediately see the changes in this tool. And it's even possible to animate them. So we have a rectangle, we have a circle. As you can see, it's similar. We have the circle is described by a center point. The x coordinate is at 80, the y coordinate is also at 80. It has a radius of 50 pixels, fill is yellow, stroke is green, stroke width is 2. The rest of these are similar. Ellipse, line. Line is defined by 2 endpoints, x1, y1, x2, y2. A polyline, which is a sequence of lines. A polygon, which is a closed shape defined by a sequence of points. Elliptical arcs, you want to create a pie chart, you can do that. Quadratic and cubic Bezier curves. And all of these classes, what they're doing is providing a declarative interface to what you already have and always have had in Java 2D. There are corresponding classes in Java 2D. The main one is called java.auth.geom.generalPath, which describes the shape. And all these properties are available in those Java 2D classes. Some of these are just convenience classes, like the star. Lets you conveniently create a star shape with any number of points. And also text is also a shape. So text has a stroke and a fill, and the shape of the sequence of glyphs determines its shape. And as I mentioned, the path is the most general form of shape. Any other shape can be expressed in terms of a path, but it's virtually impossible to understand the code. So you create paths with drawing tools. You don't program those. You can add as the stroke and fill attributes, which determine the visual appearance of the shape, can be specified with regular old colors. So we could change the fill of this circle to green. Or you can use gradients. A linear gradient gradients are smooth color transitions between various colors. A linear gradient describes a transition along a line. So if you look at the fill of this rectangle, it's a linear gradient, has 4 attributes that describe the line. And the line is given as a unit interval between 0 and 1. It's later scaled to fit the shape that you're going to fill. So here, the start point of the line is at 25% on the x-axis and 0% on the y-axis, and the endpoint is 75% on the x-axis and 0% on the y-axis. So this yields a horizontal linear gradient. The colors themselves are specified by these stop elements. So the red color starts at an offset of 0, and these are also unit intervals. And the second stop, the second color, is at the 100%, and it's blue. So you see a smooth color transition from red to blue. And there's some other properties you can set which cause the gradient to either, how it will decide to fill the extra space. The default is to pad, so it just extends the terminal color. You can also reflect it or repeat it. We also have radial gradients, which are color transitions along the radius of a circle. similar type of interface, but it describes the radius and center point of the gradient. And finally, we have texture paints, which are specified. Actually, I should mention all of these interfaces. If you're familiar with SVG, you will see these as familiar because the attributes of the gradients and the shapes are nearly one-to-one mapped to the corresponding attributes in SVG. So a pattern is a texture paint. So what it does is it takes any other visual element of any kind and it tiles it over the shape that you're trying to fill. So here I have an ellipse, which is actually filled with a triangle. I created the triangle with a polygon having 3 points. And it has a red stroke and an orange fill. So if I change the triangle, I can, and not only can you put regular old shapes, it's even possible to put swing components. And here I tiled that ellipse with the J slider. So any visual element that can appear in the canvas can be used as a texture paint using a pattern object. We have transformations, affine transformations, which is also part of Java 2D. So they're basically 4 operations. Translation, which is the origin of an object. Rotation, which rotates an object around excuse me, a center point. Scaling. And shearing or skewing, which skews an object along the X and Y axis. And then as I mentioned, it's a compositional framework. So you can take primitive shapes or other things and you can combine them together into higher level objects that can be used as a unit. So there's a group operator similar to what you have in SVG. In this case, I created a group which consists of a round rectangle, an ellipse, and a triangle. And down here is the code that does that. So this group contains, its content is a rectangle, a list consisting of a rectangle, an ellipse, and a polygon with 3 points, which is the triangle. So when I apply transformations to the group as a whole, the whole group is moved, the whole group is rotated, the whole group is scaled, and so on. And then as I mentioned, swing components are also equivalent components in this framework, in the canvas, to shapes. So here I added a JText field and a JButton to the canvas, to the group with the triangle, rectangle, and ellipse. And when I apply transformations to the group, they also, of course, apply to the swing components. Okay, so another thing that you can put into your canvas are regular old images. They can be put into a group together with all the other stuff. You can apply transformations to them. It's even possible to take a canvas itself and turn that into an image dynamically and use it as an icon, for example, for a swing component, like a JButton. Every object has a transparency attribute, or actually an opacity attribute, which uses alpha compositing to create transparency effects. So you can apply transparency to any individual element or to a group as a whole. And this example has some of the stuff from the previous one with various levels of loop. But in this case, the iterator is time. So this expression I have up here at the top, it says var I equals 1 ... 100. That means the number is 1 up to 100. Duration 1000. 1000 is in milliseconds, so that means 1 second. And linear is an interpolator qualifier. So that means it's going to do linear interpolation. So basically what happens when JFX evaluates this expression is it divides up the time interval into the number of elements that are in that array. And then at each subinterval, it returns a new element from the array. And it does that asynchronously. So I will take on the values 1 through 100, and it'll get a new element every 10 milliseconds. So you can animate any property of any object. So when you're talking about animation, it's not necessarily visual. I can animate any property of any kind of object in this language. Now, when I animate visual elements, then you're going to see visual animations. So in this example down here, I'm animating some attributes of a rectangle. So when I click the button, it's calling a event handler that applies an expression kind of like this one to the width attribute or the height attribute or the opacity attribute of this rectangle, or to the transformation that's applied to it, in this case a rotation transformation. So if you look down below at the code, here's the one that does the height. So this expression right here is the complete implementation of the height animation. Now, there are a lot of little details when it comes to animations and having concurrent animations and sequenced animations, and definitely I haven't found the final solution. It needs further development and hopefully contributions from a lot of people. Maybe I didn't mention it, but I should have. This is going to be an open source project eventually. We put out an initial release, which is sort of a pre-alpha release, which contains, it does contain some source code. It contains all the source code for the JFX part of the JFX libraries and so on, and all the source code for the demos that we had available. The interpreter itself is not open source yet, but eventually we're going to build a compiler anyway, so that code is not going to be used. So we definitely want to. I'm only one person, so I try to do as many use cases as possible. But there are a lot of little cool animation effects that people do, and I want to study further and explore further to find the most effective and efficient way of expressing those. Okay, and one of my other questions was, why do Flash programs look different? Well, they don't. They don't at all. Anything someone can do in Flash, you can do it with Java 2D. It has the capabilities. We just have to use it. So, I'm not a hater. I don't have anything against Flash. I actually think it was a good thing because it allowed a lot of these UI designers and clever people to come up with really neat effects and really compelling applications. My argument is that that really has nothing to do with the Flash player. The same results can be produced using the Java platform or even other platforms. I mean, there's Silverlight. I'm sure you can actually do the same thing in C++ if you want to. It's just pretty hard. So over the over the last year and a half, 2 years, as I've been doing this, I created quite a few replicas of various Flash programs. And it wasn't that I was going out and looking for Flash programs. I was just going out and looking at what I thought were cool programs. And I thought to myself, well, is this an example of something that I think it should be possible to deliver with this tool? And these are some examples of programs that I thought were the kind of programs I wanted to be able to do. This is an old version of a Bentley website. You can see it has like a little slideshow going on the home page and various sliding and opacity transition effects. And these little details are the things that these kind of people do because it makes the user experience very smooth and pleasant, although it's very subtle when you have fade transitions. Even this text right here that's changing, it's fading in and fading out. And all of these things were created using JFX. It's not all images. Of course, all the photography is images. But like this scroll bar right here is basically, it consists of 2 rectangles and 2 triangles. So the scroll bar thumb and the background of the scroll bar are rectangles. And the 2 buttons are just little triangles. And they're composed together into a group, and there's some mouse handlers on them and so on. And by doing it that way, I was able to I don't have I don't know if this site is still available. It's probably available on the Wayback Machine, but that's pretty much exactly what the scroll bar looked like in the original. And then in this one we have a little performance graph thing. This is all created out of vector graphics. There aren't any images here. This is a little round rectangle. This is a little round rectangle. This is text. The grid is just a sequence of horizontal and vertical lines. They're spaced to create the grid. The yellow and orange, or red, not sure what color that is. I guess red. These are polylines that are based on some made-up sequence of points that doesn't actually reflect the power characteristics of this car. And this part here and this part here are it's just regular old text that's been rotated with a rotation transform. Fading in and fading out. And even that little orange triangle right there, as it changes the selection, it fades in and fades out. This part here was just created with regular old HTML markup using the HTML editor kit that's part of Swing. This one is a recreation of something that comes from the OpenLASLO project. OpenLASLO is pretty neat. It's an XML plus JavaScript system that can deliver content for both the Flash player and apparently more recently also DHTML. But I looked at it before I ever started JFX. And you know, a lot of people ask me, well, why another scripting language? Why did you invent a new scripting language? Well, if you look at OpenLASLO or Microsoft Silverlight or Adobe Flex, they're inventing new languages, but they're XML languages. Their language, the new part of their language is XML. And from my experience, XML, although it has some nice features like declarative syntax, it has some drawbacks. We've lost something compared to real programming languages. I want to be able to factor my code the way I always have, meaning creating variables, subroutines, class hierarchies. That's what makes me effective and efficient as a programmer. I also like compile time error reporting. I want to see a little squiggly in my IDE. I don't want to see some XML parsing error at runtime. And those are things that you lost when you start using these XML-based systems. So I wanted the positive side of these XML-based systems, which to me was the declarative syntax, the query language. JFX actually has a query language with all the power and functionality of XPath and XQuery. But I wanted it in the context of a real programming language, so I could do all the things I normally do as a programmer. So this is actually a real application. Searches Amazon for some music results using their SOAP services. Has a bunch of very clever effects, very nicely designed user interface. Someone with actual art skills, not a programmer, must have done this. And I remember back in the early days of doing this, that I had seen this application. I was like, you know, that's something I would like to do. And my stuff was so far from being useful at that point, I couldn't do it. And then as it evolved, at some certain point in time, I was like, okay, let me try it again. And I was able to very easily express this program. You know, you have all the things you would normally expect to have in Swing, you still have. Drag and drop, you know. This is actually doing just drag and drop inside one canvas, but there is a way to integrate with the system drag and drop. Some of the text here, this is actually, you know, a JEditor pane that's delivering this text using HTML markup. So Swing components, any Swing components you have can be reused and you can use them as part of your application in conjunction, excuse me, with 2D graphics that you create using the JavaFX canvas. Let's see my time. Maybe we'll come back to another demo if I have enough time. So declarative syntax is a big thing, in my opinion. I think it's very clear to everybody who's ever tried to write an HTML page or compared to trying to use the Swing text APIs. You know, in HTML, if I want to set italic or bold, or set the font on some styled text and have it a bunch of styled text, a paragraph of text with various fonts and various colors and various font styles, it's got to be, I don't know, 50, 100 times easier than trying to do it with JText Paint or JEditor Paint programmatically. I mean, if you have to get a reference to the element, and then you have to get a reference to the attribute set of the element, then you have to create an attribute and apply it to the attribute set, and so on, for every little thing. So having a declarative syntax for HTML makes people who want to compose some styled text of some kind, it's much more efficient than doing it using JText Paint or equivalent. Another example is HTML tables. If you use something like JSP and you write a dynamic HTML table, like a shopping cart, using the JSTL, the Java server something or other template language, I think it stands for. But here I'm creating an HTML table, and it's a declarative expression of that table. So I declare a table, I declare a row for the header, I have a table header for a column header for the description, a column header for the price, and then I'm using a declarative iteration. So I'm saying for each item in my cart, and presumably the cart is some kind of Java bean with an items property, create a row with a column with the cell value of the description followed by another column with the cell value of the price. And that's it. And trying to do something like that with JTable is clearly much more complex and much less intuitive when you look at the code than something like this. So what I try to do with JFX is, given the features of the language, make it possible to express a JTable, for example, as easily as I expressed that HTML table. So I prepared some code which, let me make that a little bigger. Which creates a JTable using JFX. And as you can see, I created some bean-like objects. I have an item class which has a description and price attribute, attributes, and I have a cart class that has a list of items, an attribute which is the list of items. And then down here I'm going to create the table. And this is just a simple example. I declared a variable here to represent my cart, and I put a couple of items in it, a widget and a gadget. And then down here, I declare the columns. So the columns of this table is a list of table column objects. The text attribute defines the content of the table column header. And then down here, I have a for each loop, which is a declarative iteration. In functional languages, these are called list comprehensions. But I think the for each syntax is intuitive enough that you can see what's going on. So for each item in the list of cart items, create a table cell, a list of 2 elements. The first one is a table cell whose text is the item's description. The second one is a table cell whose text is the item's price. And by using the bind operator in these expressions, without the bind operator, the table and the cells would only have the initial values from the cart. But by including the bind operator, whenever I changed my cart or changed any of the properties of those items, the cells of this table would automatically reflect those changes with no further programming. You don't just have static content. You have dynamic content. It's based on the time and place and the state of your application at that moment. And, you know, the idea here is we're creating model view GUI, so I have a model, some kind of non-visual model that captures my application state. And during the user session, there are going to be dynamic changes to that model. When those changes occur, I need to take action. So what the bind operator does is allow you to create dynamic content, not just static content, but dynamic content that depends on the runtime state of your application. You can do declarative conditional logic. There's an if then else expression. You can do declarative iteration with for each. There's also a select operator, which is similar to the select operator you have in SQL. So you can declaratively express any kind of complex content. And thanks to the incremental evaluation feature, if the things that expression depends on change, the system automatically takes care of updating rather than you as a programmer having to wire it all together manually. So this eliminates the enormous writhing mass of listener patterns I was complaining about. And I want to talk about the benefits of static typing. As I mentioned, I want code completion, searching, refactoring, all the features that we expect from a Java IDE. Why should we expect less from some GUI programming language? But that's pretty much what you're going to get with most of these XML-based languages. You have no way to factor your code. You have one humongous XML document, or some degenerate forms of reuse like XML entity references or ID tags or so on and so on. So having a statically typed language makes it much easier and possible to have very high quality IDE support. It makes it much easier to generate high performance code. It's possible, for those of you who've ever heard of Strongtalk, which is a very implementation of Smalltalk that was done by the team that eventually joined Sun and built the hotspot virtual machine. They achieved a very high performance level from a dynamic language. So it is possible, it's just way harder. And all of the implementations of the JavaScripting language that I'm aware of, like Rhino JavaScript, JRuby, Jython, etc., they have not achieved anything like the performance of Java at this point in time. Oh, okay, so here's the link to where to get JFX. There are IDE plugins for NetBeans and Eclipse that you can install from the site. There's a zip tar file download where you can get the distribution, or you can check it out through Subversion. There's a certain amount of documentation, and there are mailing lists and forums have been so swamped I haven't been able to post anything yet, and I'm looking forward to spending some quality time sleeping next week before I do that. So we have about 10 minutes left. I'd be happy to take any questions.